This is the fifth of a five-part series on functions. Part 1 defines functions and provides some needed vocabulary. Part 2 considers notations used for functions and how to find function values for given inputs. Part 3 looks at algebraic operations of functions, adding, subtracting, multiplying, and dividing. It also suggests instances when the domains of functions need to be adjusted based on those algebraic operations. Part 4 looks at function composition, defining it and looking at composition both for values and for the general case. Part 5 formally defines a function inverse and provides a method for finding the inverse for a function. Examples of all material are worked through in each resource. The basic idea of an inverse function is what undoes the action of a given function. For example, suppose we have a function f of x equal to x plus 5. It seems pretty obvious that the inverse function would be to subtract 5. What does it mean formally to be the inverse of a function? The notation used for an inverse function looks like the function raised to the -1 power and is read as function inverse. The formal definition for the inverse of function f of x is a function f inverse of x such that f of f inverse of x equals x and f inverse of f of x equals x. In other words, when we do composition of a function and its inverse, we get back to the original input. But how do we find these inverse functions? First, we switch out of function notation. Instead of f of x equals whatever the function rule is, write it as y equals the function rule. Next, invert the x and y. So anywhere there was an x, put a y, and vice versa. Then attempt to solve for y. Try to get y all by itself. If this is impossible, then the function has no inverse. Finally, switch back to function notation. Write the inverse as f inverse of x equal to whatever we had solved y equal to. Let's see a couple of examples. Suppose we have the function f of x equal to 3x plus 2, and we want to find its inverse. We switch notations, writing instead y equals 3x plus 2. Inverting the x and y, we have x equals 3y plus 2. Solving for y, first we subtract 2 from both sides. This leaves us x minus 2 equal to 3y. Dividing both sides by 3, we have the quantity x minus 2 divided by 3 equal to y. Since we have successfully solved for y, we have found the inverse. So f inverse of x equals the quantity x minus 2 divided by 3. But what if we have to find the inverse for a more intense function? What would be the inverse for the function f of x equals x squared minus 4? We start by switching out of function notation. We have y equals x squared minus 4. Switch around the x and y. We have x equals y squared minus 4. Solving for y, first we add 4 to each side of the equation. This leaves us x plus 4 equal to y squared. To finish solving for y, we take the square root of both sides of the equation. We are left with y equals the square root of the quantity x plus 4. This means that f inverse of x equals the square root of the quantity x plus 4.